Gesture input is widespread in interactive systems, from touch and motion gestures to whole body and in-air gestures of many kinds. However, wheelchair users may have specific motor abilities to perform gestures with the fingers, hands, arms, and legs, depending on their health condition. Unfortunately, incorrect assumptions about the motor abilities of the average user, implicitly embedded in gesture user interfaces, create accessibility challenges for users with motor and mobility impairments. In this work, we are interested in understanding wheelchair users' preferences for on-body, in-air, and on-wheelchair gestures performed from the space of the wheelchair. We present the results of a gesture elicitation study conducted with 11 wheelchair users that proposed on-body, in-air, and on-wheelchair gestures to effect 21 referents for interactive systems. Because our analysis revealed low consensus between the elicited gestures, we examined gesture characteristics in relation to our participants' self-reported motor impairments. Based on our findings, we outline 9 implications for designing on-body, in-air, and on-wheelchair gesture input for wheelchair users, which we discuss through the lenses of ability-based design. Our study included wheelchair users with a diversity of health conditions, functionality, and motor impairments reflected by a wide range of WHODA's health and disability scores. Following prior studies on gesture elicitation, we selected 21 referents covering various system functions and types of digital content, which we grouped into 3 categories: actions, content, and navigation. To understand our participants' preferences for on-body, in-air, and on-wheelchair gestures, we employed a diversified set of measures of gesture articulation, perception, and agreement analysis. For instance, gesture locale specifies the preference to execute a gesture either on the body, in the air, or on the wheelchair. We found that about 1 in 2 gestures was performed on or with reference to the body, 40% were performed in the air, and 12% on or with reference to the wheelchair. We also extracted more specific information about each gesture locale. For example, on-body gestures were performed mostly with reference to the head, in-air gestures in front of the body, and most of the on-wheelchair gestures involved touching the armrests. We measured gesture extent, a measure inspired by McNeil's gesture space, a division of concentric squares of the space around the person performing gestures while seated. We found that the gestures performed in the center region and around the head represented more than half of the gestures elicited in our study. We also evaluated the agreement rate between participants' gesture proposals. Despite the little agreement between users, we found high gesture ratings within users. This finding suggests the need for a design approach based on a customized gesture sets adapted to the user's preferences and specific motor abilities. To better understand our results, we computed visualizations of the relationships between gesture articulation characteristics and participants' self-reported motor impairments. Our analysis revealed that the gestures proposed by different participants were different in terms of the combination of their articulation characteristics, such as gesture locale, detail, and extent. Instead of a consensus gesture set that would be representative for a large group of users, we found highly individualized gesture preferences reflective of our participants' specific motor abilities. Following these results, we interpreted our findings through the lenses of the ability-based design approach, where designers focus on users' abilities, not disabilities, and systems change to match and adapt to those abilities. By capitalizing on the principles of ability-based design, we proposed 9 practical implications for accessible on-body, in-air, and on-wheelchair gesture input for wheelchair users. For example, design gesture sets that are customizable in terms of gesture locale according to user-specific motor abilities. Design gesture sets of on-body, in-air, and on-wheelchair gestures that can be used interchangeably in the personal and peripersonal space. Reuse embedded sensors from smart wheelchairs, mobile and wearable devices to detect a variety of on-body, in-air, and on-wheelchair gestures. For other implications, please see our paper. In this work, we examine the characteristics of on-body, in-air, and on-wheelchair gestures proposed by wheelchair users for common actions, types of digital content, and navigation commands in interactive systems. Our results revealed a high preference for on-body and in-air compared to on-wheelchair gestures with specific articulation characteristics according to user-specific motor abilities. For more details regarding our gesture dataset, study, and results, please see our paper.